please get yourself a calculator so you can participate.
I have my telephone.
Telephone works fine. All we're going to be doing, all I need you to do is cube a number, okay?
What number?
Well, here's, don't tell me, that's the whole trick here. I've got two helpers that help me today, and it's Sydney's birthday. Happy birthday.
Happy birthday.
Happy birthday.
Audrey.
No.
Yes.
Yes.
Who else helps clean the table? I'm trying to remember. It was a while ago. It was Aaron. Okay. So I'm going to, there they are. You're going to get a deck of cards. This is just to randomly pick a number, red or blue.
Blue.
Blue. And Aaron, red or blue. Actually, sorry, you get red. Okay. So here's how it's going to work. Aaron and Audrey are going to randomly pick a number. They're going to write the value of that number on the whiteboard and show. Pick a marker, blue or black. You're sitting over at the phi table. Get a marker. Blue again.
I have markers.
Okay, you don't want one of these? Cool. I like, yeah, use your own. Okay. So here's how it's gonna go.
Just a random number.
You can shuffle it. People earlier weren't trusting that I didn't memorize the decks of cards, which would be amazing in itself. Equally amazing what we're gonna do today with some math. I wanna not work with squares or square roots. We'll look at cubes, but more importantly, cube roots. I'm going to do a cube root of a fairly large number. But we're going to get that number. You're going to get a 2-digit number. And here's how it's going to go. Aaron and Audrey are going to shuffle their cards. They're going to pick a random card. And we'll count ace as 1. And you'll go 2, 3, 4, 5, 6, 7, 8, 9. Let's not use the 10. That has 2 digits. And let's not worry about the face cards, jack, king, or queen. So you're going to shuffle that card. And you're going to get the value of the card. You're going to write it on the board. You're going to show everybody, because I want everybody to write or type in your calculator a 2-digit number. First digit will be from Aaron, second digit will be from Audrey. Does that make sense?
By value, do you just mean the number?
The number.
Okay.
And you're just going to write it down so everybody can see it, except me. I'm going to turn around, I'll close my eyes. I'll try not to walk into the wall. La la la, don't show me. Are there any questions?
No.
I can't see. So we're good? You got it? 2-digit number.
How you doing?
Aaron's got the first digit. Audrey's got the second. Type it in your calculator, and I want you to cube it. Remember what cubing is? Aaron has the first number. We're cubing a 2-digit number. Remember what cubing is? Multiplying by the number by itself 3 times. For example, 5 times 5 times 5 is 125. The cube root of 125, therefore, is 5, right? It goes backwards. So you're going to take a 2-digit number. Aaron gave you the first one. Audrey gave you the second. Does everybody have that in there? In their calculator? Okay. Did somebody have it in their calculator? Will you cube it? Multiply it by itself 3 times.
Don't you peek?
I'm not peeking. I'm trying to make sure people are doing what I'm asking. Cube a number. That's all I'm asking. Cube a 2-digit number. And then you're going to tell me what that larger number is. It's like 4, 5, maybe 6 digits long. Elsie, do you have it? Will you tell me the long number, the big number?
Okay, 4, 5, 6, 5, 3, 3.
4, 5, 6, 5, 3, 3.
Yes.
456,533. Is that right?
Yeah.
So I'm going to tell you what number you started with,
Oh.
because I'm going to cube root this thing. Are you ready?
No.
The number that you started with is 77.
Oh, Mike.
Boom. Are you ready?
What?
We're going to do this one more time.
Oh.
Okay. This time, let's have Audrey give the first digit, Aaron the second digit. Are you ready? I'm looking forward. La la la. Don't tell me what it is. Don't show me. Everybody see the 2-digit number. This time, who had the first digit? Audrey. And then Aaron has the second. Okay. All I want you to do is tell me what that large number is. 5 digits. I'm sensing maybe 6 digits. It's 5. Yeah, that's what I thought. You know, I was thinking 5, but okay, 5-digit number. Tell me out. What is it? 59319. Okay. The cube root of 59,319. Are you ready?
Oh jeez.
39.
The flip.
Boom.
What?
Microphone drop. Okay, just kidding. Okay, now I'm going to ask you to be a little bit patient, a little bit understanding. I'm working on this. I want to try 3 digits. Are you with me?
Ah jeez.
Okay, Sydney, it's your birthday. I want you to to also pick a card, and then Aaron, you'll write your value, Sydney's value, and then Audrey's. Does this make sense, everybody?
Yep.
So Aaron, you're gonna write 2 digits. Those are your first 2 digits, and then you're gonna write Audrey's digit, multiply it by itself 3 times, cube it. Are you with me? You got this. Thanks for your patience. Let me know when you get it. This is going to be a big number. It's like 8 digits, maybe 9 digits long. You got this? Did everybody get it?
I got it.
Okay, what is the large number?
997002999.
It's a lot of 9s. Sure is. Okay, this number. Okay, this, when I said a lot of 9s, I meant that, huh? The cube root of 997,002,999, oh my gosh, is 999.
How?
999.
He's got a little mini
999.
calculator on his
This is
microphone.
all I have written. This is all I have
Wait,
written.
teacher?
I just have the cube root.
You're not a
Okay.
teacher, you're an alien.
I want to show you how to do 2-digit numbers at home in your head. Pretty amazing stuff, pretty cool. Sounds really complicated. A cube root, what times itself 3 times is that number? Here's what you got to know to be able to do this. Your first 10 perfect cubes. You remember I asked you to learn these a little bit? 1 times 1 times 1. Let's see how we're doing. 1 times 1 times 1. We got that one, right? It's 1. How about 2 times 2 times 2? 8.
No.
How about 3 times 3 times 3? 27.
27.
How about 4 times 4 times 4?
Wait, let me do the math.
Getting a little more complicated for
30,
sure.
32,
4
yeah.
times 4 times 4, you're almost there, 64. 5 times 5 times 5? 125. Definitely gets more complicated here. 6 times 6 times 6? 216. Nice. 7 times 7 times 7? 343. And 4 times 4 times 4? I already did, was 64. How about 8 times 8 times 8? 512. 9 times 9 times 9? 729.
9.
And then the last one, the hardest one, of course, 1,000. Here's what I want you to notice. What do these numbers end in? They're all unique. And, check it out, 1 ends in a 1. Okay, maybe you're thinking, I don't see the pattern here. 2 ends in an 8, 3 ends in a 7.
Okay, I'm gonna come up and show everybody.
Yeah, what do you got? What do you got?
So, these are all the same.
And this one.
No.
Actually, even the last one.
But the other ones are just switched.
Yeah.
Numbered. So the 2 is right there,
Yep.
and that one.
Yes. Awesome. They're all the same. Most of them are the same. 1 ends in a 1, 4 ends in a 4, 5 into 5, 6 into 6, which makes it really easy. These ones just get switched around. Really good observation.
I love
2 ends in an 8, 8 ends in a 2. It's just 10 minus that number for these ones. 3 ends in a 7, 7 ends in a 3. Done, you got them. Okay, that's like a big part of it. Let's look at a number, 52 cubed. I already know it's going to end in an 8 because it ends in a 2. The number ends in an 8. So we're going to kind of go backwards now. Okay, if you type it in your calculator, so this is what you would do at home. You would say, hey, type a number into your calculator, 2 digits, multiply it by itself 3 times. If you do 52 cubed, I believe they would get something like 140,608.
Yep.
Just because I looked at that like 3 times today already. Okay, so I know it's going to end in a 2 because 2 times 2 times 2 is 8. What about the 5? That's maybe the tricky part. I know it's going to end in a 5 because of those first 3 digits right before the comma. Where's 140 on my list? I don't see it, right? But look what it's between. It's between 5 cubed and 6 cubed. What that tells me is 50 cubed is 125,000. 60 cubed is 216,000. 140,000 is right between those. It's between 50 and 60, and it ends in 2. What's between 50 and 60 and ends in 2? 52. That's it, right? So I'm just looking at those 3 digits. What's the number in my list of perfect cubes that's right below it? That's not bigger than it. And the answer would be 5, right? 125. How you doing? You want to try one out? I'm going to give you a number. I'm going to cube it. Let's see how you're doing. Let's make it not too bad on this one. Let's do this one. Ooh, I like this one. Here's the number. No calculators. Let's see if you can do it. 97,336. What is the cube root of 97,336? No calculator. Do you know what it ends in right away?
Oh, I think so.
Check with your partner. Check with your table. Here's what I'm looking at. My list of perfect cubes. That last digit, do you see it on there? Okay. What does it end in, for sure?
6.
Yeah, 6, because 6 times 6 times 6 ends in a 6. Okay, now for the hard part maybe. I'm looking at that number, 97. What number, where does it fall? Raise your hand if you think you know it. Oh my gosh, I'm seeing hands. I'm seeing hands, yes. I'm seeing not so sure over here. Where's 97? I don't see 97, right? But where would it be between 64 and 125? So that means we're going one lower. And the answer is 4. 46. This is 46 cubed. How'd it go? Try one more?
Sure.
Alright, we'll get a... Let's do... Okay, this is a good one. I like this one. Ooh, this is good. This is good. I like it. 132,651. What is the cube root of 132,651? Oh, we can't see the list of perfect cubes. It goes. Let's see how fast I can write them. 1, 8, 27, 64, 125, what is 216, 343,
Found it.
512. Nice. All right, raise your hand when you think you got it. 729, 1000. You actually don't really need 1,000. That's a double digit. Nice. Yes, I'm seeing more hands. Kind of. Raise your hand if you know what it ends in.
A 1.
Awesome. Yep.
And then I know.
You
what
could
I
even
did.
show me your fingers what it ends in. Yeah. We know because of the last digit what matches in this table. We know it ends in a 1. Here's the tricky part. What is that just above? What is that between? Elsie, you feeling it? What are you feeling?
5 and 6.
It's between 5 and 6. 5 cubed is 125. 6 cubed is too big, 216. So this number is 51. The cube root of 132,651 is 51. Something that I think sounds really complicated. How would you ever know that you could do in your head? I think that is amazing. Thank you so much for your help there. And that I feel very good about getting the 3-digit number. It takes a little bit of practice, which I've been getting. I've messed up plenty of times today. But the same thing happens with the first and the last digit. I'm looking at what does it end in? A 9. What did it start with? Those first 3 digits is bigger than 729, so I know it starts with a 9. Figuring out that middle digit takes a little bit of guesswork in some ways, adding some digits up. But I think that's really cool with those 2 digits. Really awesome.
Now we all get to pick 2 digits, okay?
Now, right.
Let's do it!
You could try, tell your partner, see if you could try it out. Okay.